All right, so one of the most powerful things of quantum mechanics and these kinds of orbitals is its predictive power. This stuff can predict a lot of stuff, and that's where science is really the most useful. Science is all about, let me build a model of something and then tell you how something is going to happen. So let's think back to kind of the beginning of the class when we said that atoms share or exchange, what we'll say transfer electrons to form bonds / react. That's what chemistry is all about. In chemical reactions, we just exchange electrons. We never mess with the protons, and so we never change the identity of the element. So chemistry all really comes down to is playing with these electrons. You can change the number of protons in an atom and thus the identity, but that's called nuclear chemistry. So that's something you'll go over in Chem 101 or 102. Anyways, back to this point. So atoms can share electrons. We remember that's a covalent compound. And so later on, we'll learn about Lewis structures, and we'll cover this later on. Probably my favorite part of the course, Lewis structures. And then the transfer electrons, if you think about transferring electrons, think back to the beginning of the course. This is an ionic bond or an ionic compound. And ionic compounds form ions, as the name implies, and ions are charged atoms, right? So +1, -1, that kind of thing. So let's talk a little bit about ion electron configuration. And remember that ionic compounds are made out of a metal plus a nonmetal. So let's take a look at fluorine versus fluoride. And so first thing you're thinking about, what's the difference? The difference is this negative charge. And think about what a negative charge means. Does that mean it's gained or lost an electron? Well, electrons are negative, so if it has a negative charge, it gained an electron. So let's take a look at our periodic table so we can do the electron configuration for both of these. So we have F right here, so we can say, oh, it's like helium, the noble gas above it, and then 2s2, and then 1, 2, 3, 4, 5, 2p5. So there's the electron configuration, and we can see this has 7 valence electrons. Then we think F minus, well, it's going to be the same thing as F, except it gained an electron. So where's it going to gain that electron? Well, we still have one more spot in the F orbital, or in this p orbital, this 2p orbital, so it's going to go there. So it's going to go 2s2, 2p6. And you can tell now it has 8 valence electrons. Let's take a look at another example of sodium versus Na+, sodium ion. So sodium's up here. So we can say, oh, look, it looks just like neon, except it also has a 3s1 electron. And if we see this positive charge, that means we lost an electron. And when you lose an electron, you're going to lose the highest level electron. So you're going to lose this 3s1 electron. And so this becomes just neon, or you can think of it as helium 2s2, 2p6. So 2 important things to note. Note that F minus and Na+ have the exact same electron configuration, right? They're both helium 2s2, 2p6. This is what's known as isoelectronic. So they have the same E- configuration. And that'll get more important in this upcoming lecture. And then again, we can see this also has 8 valence electrons. And so this is one of the most powerful parts about quantum mechanics, is that it predicts all of this stuff. So quantum mechanics predicts properties of atoms because they're based on number of valence electrons. And quantum mechanics explains about valence electrons and predicts them. So remember back in the beginning of class, we said everything in row 1 is going to be +1. Well, that's because it has 1 valence electron to lose. Everything in row 2 is going to be +2. That's because it has 2 valence electrons to lose. And so the idea, the main point here is, well, first off, let's write quantum mechanics predicts most of the found charges. Right, so quantum mechanics predicts sodium is going to be a +1, and that's true. And this is because this statement right here, filled valence shells are energetically favorable. And so this will be a huge topic later on when we get to ionic and covalent compounds. But one thing you really got to understand and accept is that filled valence shells are energetically favorable. So things generally want to have a filled valence electron. So later on we'll learn that as kind of the octet rule, and we'll go into more detail later on. But again, you can really use this kind of valence electron idea to predict a lot of stuff. Right here, everything in row 1 has 1 valence electron, so it wants to lose that 1 valence electron. So it's going to have a +1. Same thing for here. Column 2 is going to want to be +2. Column 3, generally +3. This one right here, carbon plus or minus 4. We'll see that it can kind of do both by sharing. Same thing for the other ones, right? Nitrogen -3, oxygen -2. Halogens, they want to be -1. They want to gain an electron to have a filled valence shell. So again, we learned that earlier, is everything wants to be a noble gas. Why does everything want to be a noble gas? Because they have a filled valence shell. Why are noble gases unreactive? Because they already have a filled valence shell. They're already happy that way. So once we've got this kind of electron configuration idea down, we're going to go into some properties of some atoms, and then we're going to get into the really interesting part, which is structure and bonding.